Hello students, in this video we are going to discuss 5.17, 5.18, 5.19 and 5.20 from work, energy and power 5.17. The bob A of a pendulum released from 30 degrees to the vertical hits another bob B of the same mass at rest on a table as shown in figure. How high does the bob A rise after the collision? Neglect the size of the bobs and assume the collision to be elastic, perfectly elastic. Here, in the case of perfectly elastic collision, the conservation of kinetic energy will be obeyed. So, what will happen? Initially, the bob A has speed 0 and kinetic energy is 0, but it will have potential energy. Slowly, whenever the bob A moves towards B, it loses its potential energy that converts into kinetic energy. Whenever A hits B, the complete kinetic energy of A transfers to B and A comes to rest. Therefore, when the bob A hits bob B on the table, it transfers its kinetic energy to bob B. So the reason is the collision is elastic and B begins to move with kinetic energy of A and A comes to rest at location B. So this is the answer for this conceptually with the given data. Coming to 5.18. The bob of a pendulum is released from a horizontal position. If the length of the pendulum is 1.5 meter, so what is the speed with which the bob arrives at the lowermost point, given that it dissipated 5% of its initial energy against air resistance? This problem also similar to previous one. The situation you can take initially, the bob is horizontal. It is suppose say at A, and the lowermost point means this is suppose say B, the lowermost point, and the length of this pendulum is 1.5 meter, and here completely it has some potential energy, but kinetic energy here 0, and we are assuming that it is the reference point or reference level. Now when A from position A it reaches to B, so it will travel with certain velocity. This velocity we need to find out, or the speed we need to find out. Here also we will use the conservation of energy. So what is happening here? The kinetic energy of mv square is equal to 95% of potential energy, because the potential energy is converting into kinetic energy. 5% of its energy is lost, so the remaining percentage is 95%. So here mass will be get cancelled, it is independent of mass. So V can be taken as 95 divided by 100 into GH into 2 square root of, and if you substitute the values 95 divided by 100, G value suppose say 9.8, you can take 10 also, H value is nothing but 1.5 into 2 square root of. So after simplification, we will get 27.93 and the root, its value is 5.3 meters per second. So this is the speed with which the bulb moves at lowermost point. Coming to 5.19. A trolley of mass 300 kg carrying sandbag of 25 kg is moving uniformly at of 27 kilometers per hour on a frictionless track. After a while, the sand starts leaking out of the hole on the floor of the trolley at the rate of 0.05 kilogram per second. So what is the speed of the trolley after the entire sandbag is empty? Now our answer is the speed remains same. The speed of the trolley remains unchanged. The reason is F external is equal to 0. A body of mass 0.5 kilogram travels in a straight line with a velocity v is equal to a x power 3 by 2, where a is a constant, its value is 5 meter power minus half second power minus 1. What is the work done by the net force during its displacement from x is equal to 0 to x is equal to 2 meter? That means here the velocity is variable. So displacement also variable. Now we can use the formula for work done is equal to integral of f dx under the limits 0 to 2 meter. But here f value we don't know. So what we can write, f is equal to ma, m into dv by dt. From this m into v value is given as a x power 3 by 2. So d by dt of a x power 3 by 2, that is equal to, where a is constant, ma, but here a is not acceleration, a is some constant, into 3 by 2 x power we will get 1 by 2 into dx by dt, that is 3 by 2 ma x power half into velocity. Now by putting this value here, integral of 0 to 2 3 by 2 ma x power 1 by 2 into v into dx, that is equal to 3 by 2 ma, we can take it out, 0 to 2, v value v x power half into dx, v value again you can write 3 by 2 ma integral of 0 to 2 a power x power 3 by 2, a x power 3 by 2 into x power half into dx. So that is equal to we will get 3 by 2 m a square. X power 3 by 2 into x power half becomes 0 to 2 x square dx. That is equal to 3 by 2 m a square. Integral of x square dx is nothing but x cube divided by 3 under the limits 0 to 2. That is 3 by 2 m a square. 3 will be get cancelled here. 2 power 3 minus 0 power 3. That is equal to, we will get m value is nothing but 0.5. A value is 5. So 5 square, 3 will be get cancelled, divided by 2 into 8. So that is equal to 2 ones, 2 4 times. So this value will be 50 joule. After simplification, we will get here the force is variable. That's why we are taking integral of f dx within the limits 0 to 2. We don't know f. From the given velocity, we are getting f value. Thank you. Please subscribe the channel if you like it.